Hello everyone, welcome to this new video. Today we're going to talk about data transformation. So we're going to keep working on R, but now we're going to start using a different package. It's called dplyr, which belongs to the tidyverse. So the idea of today's session is to learn how to work with, like filters, how to create new columns, how to perform some calculations in our data frame in order to answer some questions. In order to do so, we're going to use a specific data frame from the package NYC Flights 13. The dataset is flights. So we're going to learn how to use pipes. We're going to use the function filter, arrange, distinct, select, group by, summarize, count, mainly. So let's get started. So why it's interesting to use the dplyr, which is like the one of the packages of the tidyverse. So let me show you the idea. Typically in R, for example, let's say we have an array X, and it has the value from 1 to 10. That's X. So you want to find the elements that are greater than 5. So we want to create a condition, X greater than 5, greater to 5. So what you get is like false, 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 and those elements that are greater than 5, you get the true value. So now if you want to get what are the values, so we use X, which is the name of the array, and we filter it by introducing the condition. If you ask me, it's not that bad. I think it's simple to get, but at the time, like 10 years ago, dplyr, the dplyr package suggested that you can use like a better syntax, like something that is more like user friendly. So they have some verbs like filter, select, which are clear and easy to follow. So let's see how we can use like all those verbs or all those functions. Okay, so let's get started with the package for our data. So we need to install packages. The name of this one is NYC Flights 13. That's the name of the package. Then we need to load the package, remember. And then we'll be able to use the package and the dataset. So it's installing. Remember that the first time it takes time. Okay, so it's done. Now I can retrieve the desired data sets, in this case one flights. Okay, so I get the data set. So it has information of flights, a lot of them, like 336,000 flights. So the information is the year, month, day, departure time, schedule departure time, departure delay, arrival time, schedule arrival time, arrival delay, the carrier, the flight, and different information, the region, the final destination, air time, distance, and the time. Okay, so you get an idea of the data set that we're going to use. Now let's answer some questions and let's practice some data manipulation, data transformation. So let's get started working with dplyr. So first, let's create a histogram to visualize the arrival delay. That's the first question. Let's visualize the arrival delay. So we have used histograms before. From the R package, we can use hist. If you want, you can use ggplot from our previous video. The dataset is flights. and we access the desired column or desired variable. In this case, that will be the arrival delay, just to see the distribution of the variable. So we get our histogram, and you can notice that there are a lot of negative values, right? So if you want, you can see a summary for that specific variable, for the arrival delay, and as we expected, check the median. The median value is -5. It's -5 because most of the values are negative here. The mean is 6.8. The minimum value is -86. The maximum value is 1272. Okay, you have to be careful. There are some NAs in our data frame, so sometimes we will get some errors when we want to compute some specific statistic like the mean value. If that occurs, then we will need to drop the NAs. Alright, so now the second question is, okay, let's find the arrivals, the arrival delay of 2 or more hours. So let's find the flights with a delay of more than 2 hours. So we're gonna let's find those flights. So I'm gonna create a new data set with delayed flights. So you can use equal sign, or you can use the less than on the dash, and this is equivalent to the equal sign, but in R. So it's the same thing. It's like an arrow. So from flights, and here I'm going to start using pipes. So if you want, you can use like filter the data set and then the condition. That's one option. But also you can use the pipes. So let me show you how they work. The idea of pipes is like you can like concatenate multiple operations. So for example, I have the dataset flights, and then that's how you translate pipes. Then like with the flights, what you will do. So how do you create a pipe? It's just the bar and the greater than, and that's it. So it will take these flights and it's going to introduce it in the next operation. So what is the next operation? So I'm going to filter, and the desired variable is arrival delay greater than 120. And then we can see, well, I haven't we may get an error here because I haven't called the library the tidyverse. So let me go up. I prefer to, in general, when you're programming, when you're coding, it's a good practice to call your libraries at the beginning of the file, because it's easier to have control. I mean, you can do it anywhere in the file, and that's fine. But the standard is that you do it, like on top of the file at the beginning, because then you can control, and anyone can just, like go to the beginning of the file and see which libraries you are using, instead of like, just calling the libraries anywhere in the file. That's kind of messy. So I prefer to call them here, call them at the beginning. So the tidyverse, because I'm going to use filter, I'm going to use some function from the dplyr package, which is inside the tidyverse. I should have added a hash here to make a comment inside the package, because I already installed the NYC Flights 13, but that's fine. I'm gonna wait. It's taking time. Okay, it's done. So it added the tidyverse, and here's dplyr. Okay. So now let's see the delayed flights. So we get 10,034 flights with an arrival delay of greater than 120. That was the question that we were asking. You can see the information if you want, with view, and you can start computing and working with that information. Let's keep answering the questions. So let's find the flights now that flew to Houston. That means that the destination was any of these two airports. So let's find the Houston flights. So for that purpose, we use the dataset flights, and then use a pipe. I can keep typing here, or I can even go to another line, that's fine. And then filter the variable. If you check, is dest, that's the destination, right? These are our destinations, IAH, and the other one is Houston, right? HOU. So let's filter the variable destination, dest, the variable dest equal or, it's not an and, it's or, because it's one or the other, dest equal I show you. So this is the or with the bar. You can, I mean, if required, you can keep adding more ors, or we have also symbol for and. So this is how we can introduce multiple conditions. And then we can visualize the resulting data set. So Houston flights. It's important to notice that here we're using two equal signs. That's because a single equal sign, it's reserved for the assignment, and for comparison purposes we use equal. So let me show it to you. If I remove one equal sign, I will get an error. Here it says you have used the equal signs instead of the two equal signs. So it's an error right there. Okay, so here now we have the flights only. The destination is one of the two airports that we type in the condition. And there are in total 9,313 flights that go to one of these two destinations. So that answers the question. So we can create a table to count them per airport. If that's what you want. So it's a table for Houston flights. And we want to see like the airport, like for each airport, how many flights in total. It's a small table. So we have that most of the flights went to the second airport. We can create also a bar chart. So you can use gplot. Remember the data set, it's Houston flights. Houston flights. Then the mapping, so we have the statics. So here is the destination, will be the variable of interest. And remember, we're going to add a geom bar. There you go. We get exactly the same information from our table, but just in a plot. It's the same thing. Houston, around 2,000 flights. The other airport, more than 6,000 flights, almost 7,000 flights. Remember that if you want, you can change the color, those things that we did in our previous video. That's up to you if you wanna like customize your plot. Okay. So now the question here is which flights were operated by United, American, or Delta. So remember that here the carrier has two-letter abbreviation. So for example, America is going to be AA. So we need to filter. So let's create a new data set, UAD, meaning United, American, Delta. So the three carriers. To create this new data set, we need the original data set flights, and then using the pipe, so we're going to filter, and the variable of interest is carrier. That's the name of the variable. You can go back and check the data set if you don't remember the exact name. So let's introduce the names. Remember two letters. So United Airlines is UA, or American Airlines AA, or letter equal to DL. That will be Delta. So we can see the resulting data set, at least the general information. Okay, so a lot of flights, like almost 140,000. Right, and the carrier are the three, UA, AA, or DL. You can create a table if you want to count the values for each carrier. Similar as same thing that we did in the previous one. So UAD flights, the variable is carrier. Now we have the detail, the frequencies, number of flights that were handled for each of these carriers. All right. Now the next question, it's also about filters, but now it's asking about the flights that departed in summer, July, August, and September. So just be careful that in the dataset, month is not coded with the names. It's coded using the numbers. That means that we need to, so instead of using the exact name, so we have to filter using month equal 7, month equal 8 and 9. All right, so let's do that. So let's create summer flights dataset. I like the arrow, but again, you can use the equal sign. It's because the arrow is like a standard, like for our users, you will see that they use the arrow to make an assignment. And I think it works both ways. But that's weird. The other way is weird if you want to assign to the right side. That's not it's not a standard, but it works. Okay, so we take flights, and then we filter using the variable month equal 7, or month equal 8, or month equal 9. You can just visualize by typing it like this. Alright, and you get only those months. So this is one way to create the, like to answer the question. There are better ways to do the same thing. So instead of typing, like these three conditions, you might have like some flexibility. So let me show you an alternative that maybe it's I think it's a little bit more elegant, I would say. All right, but the idea is the same at the end of the day. So summer flights. Remember that when you're coding, I think that applies to any language. You can answer the same questions using different. There are different ways using your logic, or you can create. There are multiple libraries, multiple functions, methods. So there is not just like one way to, like to solve the problem. Same thing in life, right? So flights, same thing as same thing. Till now, but now in filter, of course, I'm going to use the same variable, month. But instead of typing month 3 times, I can create like a set and say, okay, month that is in the following array, 7, 8, 9. So you will see every time you are going to create like a vector, an array, you see this the C. In R, that's what you do when you're creating like a vector. So what it's going to do is like if month is in this set, then the condition is satisfied. So it's going to apply for month equal to 6, to 7, 8, and 9. And again, you will get this exactly the same result, same thing. Okay, so far we have solved the problem using filter. I think at this point you get an idea on how to use filters. Now let's work a little bit with the sorting. This is useful especially when you want to see like the minimum value, the maximum value, top 5, things like that. So now here the first question is find the flights that left earliest in the morning. That means that you want to arrange by departure time. So that will be flights, take the dataset flights, and then arrange. Again, you can do it in the same line. That's up to you. By departure time. So it's going to show us the flight with the earliest departure time. Here, departure time 1. This is right after midnight, and it increases, right? All the way until the. Oh, here we're having NAs. I think we can drop them. Using packs, we can do that. And then let's drop NAs. Okay, now in our table, in our result, now that we have dropped the NAs, at the end of the table, remember that it begins with the the first values, and then it goes all the way until the end of the table. So now you see the flights that depart at the end of the day, like 24 hours, right? Instead of the NAs that were affecting our analysis. Okay, so that's how you use arrange. So by default, it's going to arrange from the smallest to the largest value. But sometimes you want it the other way. You want it from the largest to the smallest value. So let's see how we can fix that. For example, here, now let's sort flights to find the flights with longest departure delays. So let's take flights. And then let's arrange. Since here I want to change from the largest to the smallest, I need this function, like descending order, by departure delay. Okay, so if I check the departure delay, so we'll go from the largest values to the smallest values. So we'll be decreasing. Right? Because we use the descent here in the range. It depends on the order. If you want from smallest to largest, largest to smallest. Okay. Now let's do something a little bit more interesting. So let's find. Okay, let's sort flights to find the fastest flights. The fastest flights. So there is a hint here. So try including a math calculation inside of your function. So let me show you the data set real quick. Okay, you can use just head if you want. With head, it will show you only the top of the table, so you avoid, like the scrolling up and down here. Okay, I was here. Okay, this is flights. So we want to find the fastest flights. So pretty much to find them, we need to check the arrival time and the departure time, right? So for example, the first flight that I have here. So it says that the departure time was 5:17 and the arrival time was 8:30. So that difference is going to give you, like the length of the flight, the time, right? It's not exactly in minutes. It's not exactly in minutes, but it gives you an idea. Okay, so at this point you will think, okay, so we should do arrival time minus departure time. I think that makes sense, to do arrival time minus departure time. And then we can kind of like sort or arrange from the smallest value to the largest value. So that's gonna give us the fastest flights, right? I think that makes sense. Initially, right, at least it sounds like a good idea. But let's see if it's a good idea or not. So it's fast flights, that's how I'm gonna call them. I'm gonna be equal, this is the arrow. So with flights, I'm gonna arrange. For the range, we're gonna compute the difference between the arrival time minus the departure time. Again, this looks like a good idea initially. And then let's visualize our data set. Fast flights. So let's see if it's working. Okay. So what I get is like, in this one, for example, the departure time was like at the end of the day, like 24. Like 24 hours. Like that's like the midnight, right? And then the arrival time is 54. So it's a 54 minutes flight. But it's showing that this is the fastest flight. But it is not the fastest. There are some flights of 20 minutes in our data set. But what's the problem? What's the problem? I mean, this equation makes sense. But what's the problem? So let me show it to you. The problem here is that we just have the information of the departure time. So that occurred this day. But then the flight arrived the next day. So when you do this calculation, arrival time minus departure time, you get a negative number here. You're getting a big negative number, actually. So that's why those values or those flights with negative numbers are going to be at the beginning. So you're going to be careful here. I mean, this equation will work, the arrival time minus departure time will work if the arrival time is greater than the departure time. If that happens, it will work. Let me show it to you real quick. So if I filter this, let me filter just fast flights, which is already with the desired information. I can filter it, and I can find only those flights where the arrival time is greater than the departure time. Like this one, let me see. So in this one, the departure time is, this is 1:23 p.m. and the arrival time is 1:58, right? So it's a short flight. It's a short flight. So now this one, it makes sense, this one, right? But the problem is not with this condition, it's with the other one. The flights that arrive the next day. So they will show up first in our table, and again, they are not necessarily the fastest flight. The problem is because in the way in which we are estimating this difference. Like this one. So the departure time was 24, and the arrival time was like right after midnight. Same thing with this one. Again, I'm getting these flights first just because when I do the 54 minus the 2,400, I get like a negative number, which is really small, like minus 1,000, something like that. So it's a negative far from zero. But again, it's not the fastest flight. So let's fix that. Let's fix that. I think at this point you see like we're having a problem with the equation, with this one. So we need to improve our logic here a little bit. We need to spend more time. Okay. So I'm gonna create a new variable. So with the mutate, I can add columns into our data set. So I'm going to call it difference, just to check the difference between the arrival time and the departure time. Again, you know that it's not just arrival time and departure time. It's not as simple as that, because then I'm going to have the problem with the flight that arrives the next day. And then it's because of the format of the times. That's the problem that we're having here. So the difference, I need like a condition here in this difference. So there is a function, if else. It looks like an Excel function. It's simple to use, if else. So my logic here in the if else function is, okay, if the arrival time is greater than the departure time, if the condition is satisfied, then the equation, this equation works. This equation works. Again, if the condition is satisfied. The problem is when the condition is not satisfied, in the false. If not, then how can we compute that? I want you to think that. You can pause the video. I don't want to stay silent by 1 minute. You can just pause the video while you think like how to compute it when you have this issue here. Like the departure time, it's like this one at the end of the day, and the arrival time is the next day. So it's not just the difference. So how can we compute that? Okay, so let me show you. It's just the final time minus the departure time. So that's going to give you like the time during that day, right? That difference is going to give you the time during that day, and then you need to add the arrival time. So you need to add the additional time of the next day. Again, so the first this difference is you do the 2,400 minus the departure time. So it's going to give you the time of the flight during that day, during the day of the departure, plus the arrival time. So you get the total flight length here. It's not minutes. It's just like it's close to minutes, but it's not exactly minutes. I mean, because in one day you don't have 2,400 minutes, right? Now, what we're doing here is that we're computing, again, using mutate, we're computing a new variable, a new column. So the logic is, okay, if else, the condition, if the arrival time is greater than the departure time, then that's not a problem. Then the equation to compute the difference is just arrival time minus the departure time. That's fine. But then, if the departure time is greater than the arrival time, that's a problem in our calculation. We cannot keep the same equation because we're getting like negative numbers and they're not making sense. So the way to compute the flight length actually is the last time of the day, which is 2,400, minus the departure time. So that's going to give you the time during that day, plus the arrival time. That's the time during the next day. So when you add them up, you get, the total flight time. All right. So up to this point, so we have flights. We added a new column, and now we can arrange, right? We need more space here, like this. Okay. And then this is another pipe, right? So with our original data set, we added a new column, a new variable, and then that's when pipes are useful. That when we start concatenating functions, because if you try to put, the mutate, flights inside mutate, and then the whole thing during inside the range, then it's messy. You start having problems with the parentheses. You have start having problems with the logic, and if you try to find an error, it's way more difficult. This way, I think it's more like it's kind of like more fluent. It's easier to create different logics and to concatenate different steps. Okay, so let's arrange using our new variable, difference, right? That's the name that I assigned. Remember that variable was created here inside the same expression. I can use this variable only after it was created. So the order matters. Be careful, the order matters here. I cannot arrange based on difference and then create difference, right? It doesn't make sense. Okay, let's see if it works. That's important, right? Okay, at least it's showing something. So let's check our table now. Okay, so now the first flight, the departure time was 1:23 p.m. and the arrival time was 1:58 p.m. The new variable will be created at the end, so the difference is 35. Again, it's not minutes, it's close to it, but it's not minutes. So it makes sense, it's increasing the flight length. So this is our, this is like the fastest flight. So now we're answering the question. But again, it was required to add some additional steps here in the calculations. All right. So let's continue. Okay, so the next question is, was there a flight every day of 2013? There are multiple ways in which we can answer that question. So one of them is like you can create a table with two variables, day and month. So flights, day, and with the month. So it's going to count, like the intersection of the two variables. So the different values. With month. So this is a big table now. In the rows, which is the first value, we have days, and in the columns, the second parameter, we have months, right? So you get the number of flights during each date of the month. So please notice that we don't have zeros during the month. You will see some zeros here, but again, that's because remember that during some of the months we don't have, like the day 31 or 30 or even 29, right? So that's why we are getting the zeros here. But in the middle of the table, we are not getting zeros. So it means that yes, there was at least one flight on every day of this year, 2013. So that's one way to solve it. There are other possibilities. Let me just show you another way just to introduce some functions that maybe are useful in the future. So you have flights, and then with flights, distinct month and day. So this function is going to find the number, it's going to find like all combinations that are different, right? So if you notice, you have 1 1, it means month 1, day 1, and another one is 1 2. So it's finding the distinct combinations, the distinct possibilities, the different possibilities that you have. And in total there are 365. So that means that you have the whole year, right? So that's another way to answer the question. If you want, you can put this in the table. It looks better. So it's just like you have each pair 1 time, right? And there are some 0 values at the end, again, because in some specific months you don't have the last day or the last 2 days. So it works. Either way, you're answering the question. And as I told you earlier in the video, there is no one, like just one possible solution. You will find always different alternatives. Okay, let's continue. So, which travel the least distance? So that's an arranged question. So flights, and then arrange the distance so this is distance 17. I don't know the units, you can check the help to see the units. So this is the origin and this is the destination. I guess LGA is LaGuardia, most likely, because it's New York. I'm not sure about EWR. Maybe something with Newark, I don't know. I'm not sure. We can find it. I mean, let's do it real quick. Oh yeah, Newark Liberty International Airport. All right. These are all my practice files. Okay, we're here, so we answered the question. Then there is another question about the farthest distance. I think you can answer it, remember it with the descent, but it's the same idea, range and descent in that case. Okay, let's see how to select. So sometimes we have some data frames that are like big with multiple columns, like even if you have just like more than 20 columns, 30, 50, 100 columns, then it's difficult to visualize the whole table. You can kind of like get lost easily. But most of the time you're not going to use all variables at the same time, so you just need to select some of them. So that's why you use the function select, just to pick some of the variables of our interest. In this case, we want to select departure time, schedule departure time, and departure delay. So let's do that with flights. Take flights, then select departure time, the schedule departure time, and departure delay. You can remove NAs if you want, but we're not doing computation, we're just selecting here. So again, we get our table with the three columns. So it's simple to use select. This is just to get a view of the table, but just for some specific variables or columns. Now, with this function, you can have some helpers. For example, let's say that there are multiple variables with the name time. Like inside the name of the variables, you have the word time, like departure time, scheduled departure time, arrival time, right? So you want to get just the variables related with the word time. So you can do that. It's flights. And with flights, we're going to select only those columns that contains the word time. So we get departure time, schedule departure time, arrival time, schedule arrival time, air time, and time hour. You know, like it doesn't matter in which part, but if they have the word time somewhere in the name of the column, then you're getting back, or that column is being selected. So you can this is useful. The contains or begin with. I mean, there are multiple ways to find variables here. Okay, let's okay, this is what we did. So let's continue. Let's do our final function here, group by, which is very useful. So maybe if you're familiar with SQL, you have used group by. So what is the idea of group by? In your datasets, let's say you want to compute the average or any other statistic, you know, like in one column. So if you apply the mean value for one column, so you get the mean value for every single observation in that column. But sometimes you don't want to find the statistic for, you know, for the whole dataset or for all values. Sometimes you want that metric, but only for one group or per group. So, for example, imagine that we have bookings here, like, you know, for different hotels. So, and you want to find, okay, per city, you want to see what is the average price. And so, if you group by city and you compute the average of the price, of the rate of the hotel, so you will get the average price per city, right? So, the only way to do that is grouping, using the group by. So here, let's compute the average arrival delay and the average departure delay for each pair, origin and final destination. So let's compute the two metrics. Okay, so for flights, so remember that there are some NAs, I'm going to drop them. I don't want to have problem with the NAs when I'm computing my matrix. Okay, then what I want to do is to group by. I want to group my observations. So if I just leave it as origin, for example, so if we want to group the flights that are being originated from the same airport, right? I'm gonna compute, you know, only I mean it's gonna put together the observations that belong to the same origin. So I'm gonna I know that the original question is about origin and the final destination, but I'm gonna begin just with the origin part, and then I'm gonna add the second one. It's simple. I just add it here. Then, once I have group by information, I haven't computed anything yet. Now I want to summarize. And this is what I start computing. In the summarize, I'm going to start adding columns. So we want the average of arrival delay. This is just the name of the function. This is the name of the variable or the metric, right? The average of the arrival delay for each origin is going to be computed. This is the metric mean, the name of the variable. Again, the first name here is customized, right? It's the name that you want to put to that you want to assign to the metric, right? But this is the name of the function. This is how it's, and this is the real variable that you are using to compute the mean. Now, on top of this, let's create another metric, because in the question, we want to find the two average values for the arrival delay and for the departure delay. So the average here for the departure delay. It's mean and now it's the delay. So now we have added the two matrix. If you want, we can add here the number of flights. I can do that later. And then at the end, let's just arrange. We can use the metric departure, the average departure. So we'll go from the smallest to the largest. Oh, here. Actually, I have two pipes the wrong way. I don't know why I changed the order here. You see? So it's bar and then the greater than. You didn't say anything. No, I'm just kidding. Okay. So now we're getting a table. So there are only 3 observations because there are only 3 airports in our origin: LGA, JFK, and EWR. And now we get our 2 metrics, right? The average arrival date delay and the average departure delay per airport. So you can start making some analysis here, right? So what the group is doing here is like, first it's gonna organize your observations. So which observations belong to the first group, to the LGA airport, which observations belong to JFK airport, and which observation belongs to the EWR airport. So once they are grouped, then the matrix and all computations are made only based on the group. So they are not mixed, right? That's the whole purpose of this function, of the group by. At the end, I mean, once you are done with the grouping, so you can ungroup the operation, just to avoid, you know, like any problem in the future. All right. Remember the original question. The original question was not just was not for the origin. It was origin and destination, final destination. So let's do that. Let's group for the pair. So it's going to group based on these 2 variables. So our table is going to be bigger for sure. So now, for each combination of origin destiny, we get the average arrival delay and the average departure delay, right? So now we're making like more interesting metrics. This is like where the EDA, our exploratory data analysis, it's going to start like getting more interesting when you start using this type of analysis. Again, here I said before that we can add a number of flights. I forgot to add it here. So that's the name of the variable. And count with n. I use n and parentheses. That's the name of the function. So I get in the extra column that is counting the number of flights. So the first observation here, the one with the smallest average departure delay, has only 1 flight, right? So now you see, like, you know, like you can start making like more interesting analysis here, by adding these metrics. Okay, so this is everything for now. So I hope that you have enjoyed the tidyverse, to be more specific, dplyr, and now you have more tools to start analyzing the data sets. So I'm pretty sure that during the homework you will get familiar with these functions, and maybe you need to use another functions. That's part of the process. Okay guys, I'll see you in the next video.